final talk for tonight. It's from Marek from Eki, and I'm personally super happy about this talk because I remember the tweet where he announced it, and I was super excited about the tweet. So I hope he will tell us more about the tool I'm that excited about. So give it up for Marek.
All right, so hello everybody. My name is Marek Fořt, as he already said, and today's talk is going to be about building Swift command line interfaces. And the first part will be about a tool that I built, and then I will try to show you how you could build such tool yourself. And I was just wondering how many of you have tinkered with Swift command line interfaces, tried to work with them? All right, so not many? Yeah, okay, cool. So first a little about Techie. Probably a lot of you know about it, so I'll be quick. We were founded in 2012, and there's around 60 team members, and most of us are Czech Technical University graduates. Hopefully I will become one next year, so cross fingers for that. So Tapestry, that's a tool that I have been working on for the past 4 or 3 months, and now I'll tell you something about it. So what it does, it has 2 main components. First, it provides a framework template that's built around Swift Package Manager. So if you want to build a new open source tool, this is a great way to not think about how the files should be ordered, etc. And you can just use Tapestry for that. And it also provides a simple compatibility with CocoaPods or Carthage. And then it also helps you to ease your release process of your tool with automation, which means that you get to define the steps of your release process in a type-safe editable configuration file. I will get to it in a minute. And then you run a simple command, and it does all the steps for you. Also, a side note, a lot of concepts in this talk and in Tapestry have been inspired by Twist, which is an Xcode project generation tool, and I also recommend you to check it out. It's also really cool. So this is how you create a new tool. You go to empty directory, you run Tapestry init, then it asks for some basic info like your author name, so you can provide it in, for example, in the license file, or bundle ID that's then filled in the example project. Then it asks you if you want to create a library or executable. In this case, it was library. And if all goes well, your package is generated. Pretty simple. And then how you can release your tool. Side note, Tapestry is also released with Tapestry, so that's quite meta, and I really like to use it for that. And so the way you do it, you run Tapestry release, and then you provide the version that you want to release. And then it runs the steps that you have defined in the configuration file. So for this case, it updates your documentation. So for example, if you have in your README a version, the latest version, it updates that. Or if you provide compatibility with CocoaPods, then you need to have the .podspec file. And there it also automatically updates that version, so you don't have to go through all of those files and change those versions by yourself. Then here it also checks that the project is CocoaPods compatible, Carthage compatible, and Swift Package Manager compatible. Sorry. And then it actually updates the version, which means that it commits the changes from the updating docs step and creates a new Git tag and pushes it to the Git remote repository. And now to the configuration file. This is how it looks. It's inspired by a package.swift file. It works in a similar way. So this is a normal .swift file, which means that you get all the benefits of using Swift language. So besides syntax highlighting, which is obvious one, you get a type-safe code, and you also get auto-completion. And with that comes that you also get the documentation of all these methods or all these enums, etc. You get this documentation right inside this file, because when you start typing release, for example, it will tell you that there's this structure available, and since the code is documented in the package description, which gets imported here, you get also how all the documentation from that library. So I think it's pretty cool, and yeah. And so we implemented it, for example, for in the Swift organization, they also provide a tool for working with Xcode project file, and the tool is called Xcode Proj. I don't know if you know about it. It's also quite cool. And so the release steps got quite long and tedious, and for a newcomer, it was really frightening to see this and try to go through these steps, and there's a whole lot of stuff that can go wrong. And so when we introduced Tapestry, the list has become much more shorter, and well, hopefully these two last steps we will be able to cut those two in the future, but these are GitHub related and that's not implemented yet. And so now to the second part of the talk, which is how you could build such a tool yourself. So Swift Package Manager, well, it not only supports Swift Package Manager, but Swift Package Manager is open source, and so that means that you get to also use the libraries that they use internally for the project itself, and it has quite a lot of cool stuff that you can use for command line interfaces. So why would you use those? Well, you get to eliminate a whole lot of dependencies because, well, you just import Swift package and you're done. Instead of, for example, if you want to work with absolute paths and relative paths, you have to have some dependency for that. Then if you want to create your own commands for the tool, you have to add another dependency for that, and it goes on, and usually most of the stuff is already implemented there, so you don't have to do anything, just import it and use it. And it's obviously also closely aligned with Apple standards, which makes sense. But that means that also the API of the tools that you use, or of the Swift Package Manager, they push you to write the code in like an Apple way. Minus is, as obviously, lack of documentation. So there is no like GitHub page that you can go through. Usually the only documentation is the documentation in the source code, or well, tutorials, but I don't count those. So now let's see how you could create your own command. So this is a command registry. It's a simple place that you can define all your commands in. You can define all of your commands in this one place, and there are basically only two main parts. Is the argument parser and the commands array. Both are from the Swift Package Manager. And then in the initializer of the command registry, we initialize the argument parser with the name and the usage. These are we have to provide these values, and then we just register these two commands. We'll show you how to create the release command in just a minute. And we add them to this array with the parser that we have initialized here. And then when we run the command registry, we just process the arguments from the user. These are almost everything is also from the Swift Package Manager. And then from the parse arguments, we find by the name of the command, which is this dot command, we find which command we want to run, and we run it with the process arguments. And so this is how the release command can look like. It just has to conform to the commands protocol, which means that you have to provide the command name and the overview of the command, and it has to be able to be run with the arguments from the argument parser that you have just seen. And so the other stuff is optional, so you can define your own arguments. In this case, I want to have a positional argument, which means it's determined by its position. You can also have an option argument, which means that it doesn't depend on the position, but it depends on the prefix with double dash or dash, as you are probably familiar with working already. And it takes an input of version, which is actually also from the Swift Package Manager. And this means just that it takes as an input a string, which has a major, minor, and patch version. and it converts this string to a struct that you can then use in a type-safe way around your code base. And so we have this parser, and we just need to add the argument, and then we actually run it. We use this property, and we just get it, which means that it returns an optional. So we need to throw an error if it was nil, and then we can do all sorts of logic down there. And then in the main.swift file is a file that all the Swift executables are run from. Then we just initialize it and run it. And yeah, that's how you can implement your own command. And well, sometimes things go wrong. And it's, I think, more important in the in the command line interfaces to treat the errors as first-class citizens than in the applications. And so I think there are a few guidelines that you should follow and that will make your CLI more reliable and better for your users. So I think that you should make your errors actionable. What I mean by that? Well, I mean that if an error occurs, the user should immediately know what his next step should be and what he should do with what went wrong. And if you don't know what went wrong and don't know what the next step should be, you should at least provide enough information so you should be able to debug the problem. And then definitely make them part of your testing process. So make the test cases for them, test even for specific errors. I will show it a little bit later. And also it's a good thing to let errors, as you can say, bubble up and handle them in one place. So it's more easy to reason about the code. And also if you want to make for example, some custom printing of the error, you get to do it in this one place, and it's, yeah. So this is just revisiting comment registry. Not much has changed. We only now handle the error and print it in this one place, and usually most errors should fall through this catch statement. And an error example, which I think is follows those guidelines, is when you run, for example, a Tapestry release, but the version already exists, so you obviously cannot release it again. So it tells you that the tag already exists, and then it tells you what your next steps should be. So you should either delete the tag or probably use a different one. And now a little bit about testability. I found the best the combination of dependency injection and then shared dependencies for the most used ones and for those that don't hold any state. So that means that it's still easy to write new components because you don't have to import or import in the init all like system for interacting with the shell, etc. But you still get the flexibility of stubbing and mocking everything. And as I said, test for specific errors. So when you expect that something goes wrong in a certain way, you should test for it so you know that there are no regressions in this regard. Then I think you should wrap what you can. So for example, it might be tempting when importing some dependency for interacting with shell, just use those commands directly, but then you are dependent on the creator of the tool that they provide a good stubbing methods. So, and it also makes your code less flexible in the long run. And you should strive to be in a state when writing tests is as fun as writing new functions. It probably will not be, but at least strive for that. So this is an example of how we interact with the shell in Tapestry, or in Twist actually. So it's a simple wrapper around Swift Package Manager Utilities process that handles everything, almost everything for us. We just provide it with the arguments, which is array of strings, and we run it and throw So pretty simple stuff. And then we provide also a shared instance that we can have around the code base. And then we have a shared test case, so we ensure that we always get a clean slate before running each test, which I think is really important. So in here, we define a mock system where we can easily stop error commands or successful commands, etc. And we always reinitialize it. And then when we test for a specific error, we get to touch the mock system we have defined just earlier. We stop the command using a simple convenient function. And we expect these three parameters to be run from this function. And so we stop it with an error. And then when we actually run it, we assert that a specific error has been thrown. That function is also a convenient function, but I think everybody can build it yourself, or you can look on GitHub, etc., or just ask me after the talk. And so if you made other options, this test could maybe be a little bit longer, but I think this way is quite easy to reason about, and it's quite readable, and it was actually fun to write. So just some takeaways from this talk. I recommend you to use Tapestry to automate your release process, obviously, but I mean, it has a broader message that you should probably strive to automate any tedious task that you encounter during your development. And then think about using Swift package manager libraries, because they have a lot of interesting stuff and can make your development quite easier in the long run. And definitely treat errors as a key part of your tool, because they are really important in the command line interface. And ensure good testability, so you can always achieve high test coverage, and also that the contributors will want to write those tests, so it's easy for everyone. And that's all from me. Thank you, everyone. I don't know if you have any questions. All right. What? Yeah, we have some. It's me who's ugly, I know. Okay.
It's outdated presentation template.
Yeah, all right, so I think we're good. Thank you.
Thank you very much.